Regarding model representation scenarios and events, I think it's just useful to understand how this all works. I must be quite honest, it took me quite a while to figure it out on my own. It's actually quite simple. There isn't really much to it, but let me show you in any case. Okay, so firstly, I did show it briefly how to set up model representations. So as you saw previously, you can have multiple assemblies inside your model and reorganize them any way you want. So I think what I'll do is I'll make that part of the original, and I'll just ignore those guys. Let me just delete them for now and work with this assembly. So we have this capability to solve sub-assemblies or parts individually, or we can create model representations. Now this opens up a whole new list of possibilities, which means you can have shell representations of a part as well as a beam representation, as well as a solid representation, as well as different designs. And when you define a new model rep, you can purely activate which ones should participate and which ones not. So in this case, I have this previously created model rep, which shows which parts are active. It also shows joints and connectors because those are important as well. So if I were to create a new model rep, I'll just say add representation here at the bottom. And by default, everything will be included. So if I, now I could have just solved it directly. I don't need to create a model representation, but if I want to exclude stuff, I need to create a model representation or solve them individually. But this model assembly at this stage now has everything included there. Or as previously, when I only modeled that assembly, I could have just solved that, or I could just say, okay, I want to create a model assembly that excludes this bracket, primary bracket number 2 over here. So let me just show you how that would work now. If I now put this into the analysis scene, you will see that bracket disappearing. So this is a nice way of knowing what participates in the analysis and what doesn't. So what disappears is not part of the model representation, and what is visible is part of it. Okay, so that's how model representations work, and now it's just a matter of either exporting to Nastran or solving it inside Apex. With regards to the studies, we have different terminologies. We have scenarios, and we have events, and we have model representations. So you can have a model representation inside a scenario. In this case, we had this particular model representation. In that scenario here, we had a similar one. I think they look all the same. Just want to check. And then we can have various events. So events are what we used to know as load cases, whereas scenarios refers as well to the load cases, but also to the model representation. So this is just something to understand. A scenario isn't strictly a load case. It's a combination of load cases as well as a particular model representation. So for each model representation, we can now have various events. So we can add events, and for every event, we can then also modify which loads and boundary conditions should be active. So here we have 2 events, and in both cases, they had nothing active. Right, so the moment we then solve the scenario, it will solve the model in that particular representation, as well as those various events or load cases. Okay, that's the one thing. Section view I did mention. The limitation with rendering the thicknesses was the fact that you couldn't see sections that didn't have a thickness, and then that became quite a challenge to find them. So through this view, it just makes it much easier to find a section without a thickness. So for instance, if I were to delete, I don't think that section is actually applied here anymore, but if I were to delete one of these sections, I now sit with an unmeshed a body without a thickness, which I can now easily see over here. So that's a nice way of finding parts that you haven't assigned thicknesses for, or where the automatic thickness may have failed. All right, frequency response analysis, advanced mode surfacing, and cat cleanup. I didn't get to actually prepare my own model, so I'll cheat and show you where to find this on the internet, which is probably much safer in any case. This was already introduced in Apex Forza, and it's a YouTube movie on frequency or what's new actually. It wasn't that well marketed, and it's actually a brilliant demonstration of frequency analysis. And I just skip to 12 minutes into the video where the demonstration actually starts, and this shows very useful, very realistic frequency analysis on a exhaust silencer. And what is particularly important for you to know is this capability that they've made available in the post-processor when looking at frequency response analysis. This is something that's never been this easy to visualize and see, specifically with regards to the modal participation factors and how you can now actually interact or predict the results based on certain changes that you may have made. So they've defined a frequency dependent input force at various locations. They've defined the sensors, locations where you would like to measure the frequency response. And what you can also look at immediately is the participating modes. So it shows you the weights of each participating mode, which you can then visualize as well. So you can actually see what does the actual mode look like. And then you can interrogate the model and play what-if studies. So what if I were able to move the natural frequency of mode 7 with 30 hertz, and it can predict the result for you to say, this is what it predicts, how the frequency response would look like. So I really, this is the point in the video where they now play this what-if scenario game, and you can see the predicted lower modal amplification, in this case for a particular shift in some of the input properties. So I really recommend you watch this video. If you just Google what's new in MSC Apex Forza. So it actually dates back to the Forza release already. Very, very useful, very easy to use technology, specifically if you think it's a difficult topic and it's something that you don't understand and you don't know how to do this. It's really, really easy to use in Apex, and you will actually find that very useful in your toolbox of tools, specifically when you look at opportunities for new, maybe consulting work or new ways to look at your model. All right, and then lastly, for those of you who are still available, and not new to Apex, maybe just in terms of complex mid-surfacing. So for instance, if we look at any of these solids, how to generate the mid-surface quite rapidly for a complex solid. All right, so I'm just going to focus on this guy. We can see a few challenges here. Here are some fillets and thickness variation, etc. But as I said, I always jump right into the constant thickness tool to see what it does, and what does it miss and what doesn't it miss. In this case, I don't think it's done a bad job, to be honest. So I'll probably just go with that and show you a few tricks. One being the auto extend tool. Now this is, remember, if you like to use the stitched method. Otherwise, if you want to use the glued method, you could most probably leave these gaps. Just use your auto extend tool. Find a larger gap. Select all your bodies and have them automatically extend. You can also create surfaces using the filler tool. Create bodies manually like that, or automatically close holes like that over there. And then you have a stitched body that you can now mesh. Terrible. Just refine that. It's almost neat. And then quite useful is the ability to interrogate mesh quality. And quite important is to check the invalid section over here. And in this case, there are 5 invalid elements that I don't know of. And to find them, you can either visually look for them, or in large models that becomes quite difficult. And then you choose the right-click and isolate and enhance option. And it automatically shows you that there was problems over here with the geometry. And you can add some elements by growing the mesh. And if you zoom in closely, you can see, oh, wait a minute, there were some few edges left that didn't clean up so nicely. So we can fix this quite quickly by simply dragging the vertices of the geometry, and our mesh updates along with it. So if we now enter the element quality, I see there's still one invalid element left. I wasn't aware of either. And let's see where, oh, stuck here away in a little corner, we have some small features that were left from the cleaning process or the mid-surfacing process, and those create invalid or sliver elements. All right, and that's a very quick way of also finding out where you have problems with your CAD geometry. If I didn't do it that way, so let's reintroduce those errors by undoing a few times, and I'll even delete the mesh. If we didn't do it that way, we could have also found them using the geometry cleanup tool. And now the software actually shows you a little list of all these features, even before you've meshed. So that's another nice way of finding little problems, fixing them, skipping to either refreshing the list or skipping to the new problem area. And here we can see those other areas. Just another quick check to see where these problems are, and you can now fix them before you've even meshed. Okay, so I think that's it for today. Thank you very much for everyone attending. If there aren't any other questions, we'll leave it at this. Don't hesitate to ask any other questions. You can send me a mail